Hey everybody, this is Scott from the ThreeFold team, here today with a video on the Farmerbot. This is the long-awaited power management feature for the ThreeFold grid that allows ThreeFold nodes to shut down when they are idle and just boot back up occasionally to prove that they exist. I'm very excited to be showing off this feature and showing you how it works and how you can get started with the Farmerbot yourself. We just released Farmerbot on testnet, so it's not yet available on mainnet, but you can start testing it on testnet right away. Our overview for today, we're going to see how to install the Farmerbot on an Ubuntu host. If you're using a grid VM on the ThreeFold grid, I recommend that you get a full VM just to be able to follow along with the demonstration today and have things look the same. This could also be a VM running on a different system. It could be Ubuntu running on bare metal or a different variety of Linux. Most of what we're doing today is not specific to Ubuntu, so really just some kind of Linux system that is available all the time to manage your farm. This could be running on one of your own nodes or a node somewhere else. We're going to, after install, we're going to test that the node responds to our power state changes that are coming from the Farmerbot, and we'll test that against a couple nodes in my farm here at home. And then we're also going to talk about how to handle persistence in case the host happens to reboot. We want to make sure that the Farmerbot comes back up and continues to do its job. All right, let's jump right into it. So I've already provisioned myself a VM on my local system, and I can connect to it with SSH. In case that you're using a VM or a system in your own network, you just SSH in like you normally would. And I'm going to go ahead and switch user to root. It's just going to help. We won't have to type so many sudo commands throughout. And I'm going to run wget get.docker.com. This is a link that allows us to download an install script. I'm just going to save it to a file called docker.shell. This is a convenience script from Docker to install on a Linux system, and I can run this script with the shell command. Basically what this is going to do is add some repositories to our system here that will allow us to get the latest Docker packages straight from the Docker project instead of using the packages that are built into Ubuntu or that come from the Ubuntu repositories, which in some cases can be a bit too outdated actually to do what we need to do with Docker Compose for the Farmerbot. So this is going to go ahead and install Docker. It's also going to install Docker Compose plugin that we need. So this is good. It's going to give us all the tools that we need to run the Farmerbot. Over here in our web browser, while that's finishing up, this is the page from the Docker documentation about how to install Docker Engine on Ubuntu. This gives you more details about what this script is doing and how you could run these same commands manually. The link to the script is down here below, and there's also instructions for some other varieties of Linux, so you can find this page with a quick search if you're curious about installing the latest version of Docker and what's happening with that script. Now let's check out our Farmerbot repository on GitHub, github.com/3foldtech/Farmerbot. This is where the code for the Farmerbot lives. We're just going to be grabbing a couple of pieces of text out of here, and then Docker will be downloading the Farmerbot code itself. So in here, I have a docker compose.yaml file, and what I want to do is there's a raw button here. I'm going to right click and copy the link address. We could also just copy this text and paste it into our terminal. But by copying that link address, now I'm able to come back here. our Docker installation has completed, and I can just wget and paste in this link, and that's going to download that Docker Compose file into my VM here. Quick detour, I just want to show when Docker installs on this Ubuntu system, it's going to go ahead and enable the systemd service. So if I run system control status Docker, we'll see that the service is running and it's also enabled. This is important for later because this means that Docker is going to start up automatically anytime this system boots up. And that's a nice feature of the full VMs and the install process on Ubuntu. That's already taken care of for us, so we don't need to worry about it. If you try to use a micro VM for this on the grid, you're going to have to start up Docker yourself and be responsible for starting it up in case of reboot. So just quick note about that. I've downloaded the docker compose.yaml. I'm actually going to go ahead and make a new directory. We'll call it QA because my nodes are currently on QAnet for testing. And I'm going to move that Docker Compose file into this directory just to help us to stay organized. Now, if I return to the GitHub page for the Farmerbot, we check out the README here. There's a lot of information about the Farmerbot, how you might set up a development environment if you were working on it, how it works in detail technically. The section that we're interested in here is running in production. Now it's going to tell us that we need a .environment file next to the Docker Compose file with these contents. So let's go ahead and copy this. And we can use nano in our terminal for a simple and easy to use editor. And I'm going to type .env, that's the name of the file. And then I'm just going to paste in what I copied earlier. In my terminal emulator here, I hit Control-Shift-V to paste. That can depend on your SSH client and your terminal. Up here, I need to enter the mnemonic seed phrase for the twin that owns the farm I want to manage. So I'm going to type in my secret words here, whatever they are, 12 or 24. And this is also important. The example is showing us how to set the Farmerbot up for DevNet. In my case, if I was using QANet, I would replace all three of these instances of dev with QA, or if it's test, then you write test here, and they need to all be the same, of course. If you're running on mainnet, this is kind of one special case. These links are just going to look like this without that additional word in there. So this would be mainnet. As of when I'm creating this video, the Farmerbot is not available on mainnet. So for our purposes, this would be QA. And these links are for the relay, which is how the reliable message bus is going to communicate with the nodes, and also the TF chain link itself. We don't need to worry about that too much. This relay should be the same default relay that is used for setting up the twin. That's one thing that's important. You do need to make sure you have a relay specified on your twin before you try to use the Farmerbot. So if your twin was created on a previous version of the grid, you'll want to go into the dashboard and make sure that you have a relay. All right, so in Nano, I hit Control-O to write the file out. It's going to have me confirm the file name. I'll just hit enter and then Control-X to quit. All right, so now I have a docker compose.yaml and I also have a .env. I'm going to make another directory here called config. That's important, it needs to be called config. And I'm going to create a configuration file within the config directory. I can name this whatever I want to, it just needs to end in .md. So within the config directory, I'm going to create a file called config.md. And let's go back to our GitHub repository here, and I'm going to scroll down a bit. It's got some instructions about how to start the Farmerbot. But way down below here, we have an example of a configuration file. So you could just go ahead and copy this as a starting point if you wanted to. I'll note here also you could copy this into a text editor running on your local system if you wanted to make the changes there before you paste it into your VM or your host system. So that's up to you. Let's just take a look at the sections here. So these are the nodes, and each node starts with a line like this, 2 exclamation points, farmerbot.nodemanager.define. And then we have some required fields, 2 required fields, which is the node ID and the twin ID. And we have some optional fields, like whether or not this node has public config, whether it's a dedicated node that can only be rented as dedicated, whether the node is certified, and how much CPU over provisioning is allowed on this node. That just means how many total CPU reservations can be made versus the number of available CPUs. So if this is set to 1, it'll always be 1-to-1. If it's set to 2, then people will be able to reserve up to twice as many CPUs as are actually present in the node. But that's all optional. So here we have a couple more example nodes that just have the 2 required fields, the node ID and the twin ID for the node. If you don't know the twin ID for your node, you can find it in the dashboard. So here I'm in the dashboard, Explorer, Nodes, and I can select any node. I can see its node ID, and then I can also see its node twin ID. So this is unique for every node, and it needs to be correct, otherwise the Farmerbot won't work. So I put the node ID and the twin ID that I see in the Explorer in here. This is the farm configuration block. So we put in our farm ID and how many public IPs that we have. For most people, this is 0. You want to change that and just enter your farm ID. This last block is optional. It allows you to specify the wake-up threshold. So this is how full a node gets with deployments before we wake up a new fresh node. And then we can also set the time at which the nodes wake up. I think this should be in the local time that's set for the system, but I actually haven't tested this, setting this explicitly. So if you test this and you have any issues with how the time is working on your system, let us know and we'll work on helping you with that. I think that's going to depend on the time zone that's set up in your system. So once we've edited this config file to our liking, again, we can hit Control O to write it out and Control X to exit Nano. Now, at this point, we are ready to run the Farmerbot. So again, we have our .environment, we have our Docker Compose, we have our config directory, and inside our config directory, we have our config file. So everything is set up the way we need. And to run it, I'm going to run Docker Compose up, and this is going to go ahead and download the container images. It's going to take some time, and I don't want to bore you guys by waiting for it. So while that's happening, let's check out another installation of Farmerbot that I have here on my local system, and it looks just like the one that we set up inside the VM, except this one's configured with my actual seed phrase for this farm of mine on QANet, so we can actually run it and it will work. So let's just check out the config file. In this case, I have 2 nodes, and there's another field actually here that I didn't mention before, which is never shut down. This is a way to tell the Farmerbot that we don't want to shut down a particular node. So if you have one node in your farm that you want to use as the one that stays awake and wakes up the others, this is how you specify that. And in this case, this allows us to also just say that we want both of these nodes to remain awake. And the Farmerbot in this case is not really going to do anything until we change those values. So I can show you running the same command, docker compose up. It's going to use the existing containers, and it's going to just query some information about the nodes, and then it's going to enter a loop where it just waits for some new information. Because these nodes are set to always be online, it's never going to shut them down. And that's kind of boring. So let's go ahead and stop that by hitting Control-C. I do want to show you the two nodes that I have configured are currently up. This is the ILO integrated lights out management interface from HPE, which is a very convenient way I can, in my browser, see we have node 15 and node 14. And we're looking at the console that you would see if you had a screen attached to the node. And this is very cool for testing because I don't have to go down into the basement and see what's happening with these nodes. I can just check them here. So let's see if we can get the Farmerbot to shut down one of these nodes. I'm going to do that by editing my configuration file and just removing this line that says never shut down for node 15. I'm going to save the file, and then I'm going to run the Farmerbot again with the same command, docker compose up. And Farmerbot's going to go through its normal process here. It's going to query some information. And pretty soon we're going to see it issuing a power state change for node 15, which we've now specified can be shut down as needed. So let's see what's going on here. We have set node power. And then down here we have apply extrinsic, and let's check what's going on the node's console. So now the Farmerbot has put a message into TF chain saying that we want this node to shut down. And if everything goes well, as soon as the node sees that message, it's going to go ahead and shut itself down. There it goes. So you can check down here, power off, and that node is shut down. So that's pretty cool. And we can go ahead and stop the Farmerbot. Now, in order for your nodes to work properly with Farmerbot, they need to have wake on LAN enabled. And in order to make sure that the node actually can come back up when the wake up time comes, we can go ahead and test it just by setting this configuration file back to the way it was. I'm just going to copy this line and paste it in there. So we're going to tell the Farmerbot that we want both of these nodes to always be online. And then we'll just fire up the Farmerbot again, and it's going to just go through the same process. So it's going to check on these nodes, and when it's ready, we will hope to see that this node is booting back up when the time comes. See what's going on over here. So again, we see set node power, and we should see the grid client. Okay, it's executing the extrinsic, and back over here, the node is now booting up. So that's good news. That means that this node is properly configured, and if we set it to shut down when it's not needed, it should power back up successfully. And that's great. So we've been able to see the Farmerbot in action. It's shut down the node. It has signaled to our other node that's still awake to wake that node up by sending it the so-called magic packet over the LAN. So we know that our nodes are properly configured, and now we could set up this configuration however we want so that one node stays asleep until it's needed. And that's pretty cool. Let's go ahead and pop back over to our VM and cover our final bit, which is how to make sure that the Farmerbot will will stay alive if we ever need to shut it down. Before we do that, I'm going to just go ahead and copy over my config files into the VM because we'll need a valid configuration just to make sure that it's working properly. So to do that, I'm going to use SCP, and this is a utility that copies files over SSH. And I'm just going to copy my .environment and just copy that into, okay. Copy my .environment and my config.md, copy that into the VM so that we have valid configuration files in there. I didn't want to overwrite a file. And over here we can see that inside our VM, the Farmerbot attempted to start up, but it failed because it doesn't have a valid config. So that's fine, but now we have these containers downloaded and we can try again with our valid configuration files, which are just in the directory above. We can see that up here now we have a .environment and we have a config.markdown. So let's just copy those files from the directory above to the current directory. So overwrite the example configuration files that were in here with our legitimate configuration files that I copied with SCP. And let's take a look at what's going on inside of our, let's use nano. Check out what's inside of our docker compose.yaml. So there's a lot of stuff in here, and we don't need to cover all of it. At the top level, we have services, and there's 4 different things. There's 4 containers, 4 services that make up the entirety of the Farmerbot deployment. One is the Farmerbot itself. One is the reliable message bus peer. One is the Grid 3 client. And the other one is Redis. Now down here in Redis, we can see what we're interested in, which is this line, restart always. And this is telling Docker that we want this container to restart anytime that it might happen to die. And that's including if the host machine were to reboot. Now, as of the time I'm making this video, only the Redis container has this specified. So if we want all the containers to work this way, we just need to add this line. For each one, we can put it after image like it is. It shouldn't matter where necessarily that it goes. What's important here is that we put 4 spaces and just type restart : space always. And we'll do that for the RMB peer. Restart always. And we'll do that for the Farmerbot. Oops. Cancel. Restart always. I'm going to go ahead and Control O, write this file, Control X to exit. There's other ways that we could ensure that the service starts up in case of a reboot, but this is just a nice and simple way to do it. And Docker will take care of this for us. We just need to specify that in the Docker Compose file. Now I can run Docker Compose up, and this time I'm going to add this D flag, which will demonize or daemonize it, and run it in the background so that we get our shell back. And it's just going to wait until all of the containers are started and healthy. This can take a few seconds. All right, that looks good. And I can also now run Docker PS, and we'll see that we have our 4 services: Farmerbot, RMB peer, Grid 3 client, and Redis. And the status for each of them is up. So that looks good. And just to convince ourselves that this is going to work, let's go ahead and reboot our VM. This will take a little bit of time, but once the VM comes back up, we can check and see what happens. This is just to simulate a reboot due to power loss or something like that. And we should be able to convince ourselves that this deployment is fairly robust. One thing I'll mention while we're waiting for the VM to boot back up is that you can only run one copy of Farmerbot per farm at a time. So there's no way to say run 2 Farmerbots in case one goes down. Hopefully in the future we'll have some different kinds of ideas about how you can make the Farmerbot more robust and maybe have it running on 2 systems with failover or something like this. But for now, it's just important to make sure that your Farmerbot is running so that it can wake up the nodes, and the nodes can log on TF-chain the fact that they do in fact exist. All right, so let's try SSH. This should connect as soon as the node boots up. All right, that looks good. Let's go ahead and switch back to root and run docker ps. So this is showing us that 3 of our containers are up. The Farmerbot is still restarting, and now Farmerbot is up as well. And we can also run, if we switch into our QA directory, we can run docker compose logs, and this is going to show us the logs coming out of everything. We're going to see a lot of errors here because it needs a bit of time before all the services get started up. If I give F, then we will follow the logs, and we can just give a little time for everything to start working and to see this output, which is the Farmerbot telling us that it is basically just running idle now and making sure that it is able to connect to the Grid 3 client. All right, so that looks good. We have our Farmerbot installed. We have our configuration file set up. We have configuration in our VM so that if it happens to reboot, the Farmerbot will come back online. And now if we were to leave this running with that config specified so that one node powers down, that node should power back up on a daily basis. And yeah, that's all there is to it for the Farmerbot. I hope that you'll give this a shot, test it out. If you run into any issues, you can let us know on Telegram, or for extra credit, you can go ahead and open an issue on the Farmerbot repository yourself, and we'll check it out as soon as possible. Once we're feeling confident that the Farmerbot and all features that support it are sufficiently stable, then we'll be releasing this to mainnet. All right, again, my name is Scott from the ThreeFold team. Until next time, see you later.